Good morning, everyone, and welcome to Plexus International's webinar, Improving Incoming Product Control Using FMEA, Three Main Principles. I'll be your moderator and support this morning, Chris Peterson with Plexus International. And our speaker today needs no introduction, Jeremy Hazel. Welcome, Jeremy. Good morning. Like I said, I am your moderator for this session. So if you do need any support, have any questions for me specifically, please do use the chat as we run through today. Any questions for our trainer or regarding the content or for Plexus in general, please do use the Q&A. We'll get to those questions at the end of our session, or we'll get back to you following today's event. And as we go, if you need more information or would like to watch some shorter videos about incoming materials, feel free to check out our blog or YouTube page. There's some great content with a guy you might recognize. With that, Jeremy, I'll hand it over to you, and thanks again.
All right, folks, welcome to the hour. We're going to go ahead and we're going to be talking about improving incoming product control using FMEA. Now, hopefully, if you got here, you realize that we don't improve incoming product control by using design FMEA. The FMEA we're going to be talking about here for today is going to be the PFMEA. Now, a little bit about what this content is and a little bit about what it is not. When I go from company to company to company, what I've put in here are the three principles that I have found companies are lacking when they have less than stellar incoming product control. Now, for those of you that are out there in webinar world, lack of control when it comes to incoming product typically means we have incoming inspection, but yet incoming inspection frequently misses things, passes defects onto our manufacturing lines. And so we need to find a way to approach this topic that improves the quality of the incoming inspection. Or now here's where we start talking about what we're going to talk about. We then realize that incoming inspection is largely ineffective, and we put the responsibility onto the actual stations themselves. Now, when I start talking about this, the first thing a lot of participants feel at this point is a sense of confusion, because most of us have cut our teeth on the idea that incoming inspection is there to protect us, and that incoming inspection is in some way infallible. But I'm going to challenge all of that today, and I'm going to ask you to open up your mind a little bit and take these principles in and understand why how you view that act is largely responsible for the poor performance that you're most likely experiencing. And to combat that poor performance, we're going to be using the FMEA. So part of that is I'm going to teach you how to view the PFMEA differently so that you can make better informed choices when it comes to incoming product. So let's go ahead and take a look here at the agenda, right? Because if you've been on a webinar with me, you know I like to share the roadmap. Now, the first thing we're going to do, introductions. So my name is Jeremy Hazel. I do a lot of the webinars here at Plexus. A lot of you out there in webinar world probably know me. And the first thing that I wanted to talk about is why the webinar was needed. Because unlike some content that we create, where we create it because it's a niche topic, this is one of those things that as we travel through dozens and dozens of plants every year, we see it's a real need in the industry. And with the publication of the AIAG VDA FMEA, we need to understand exactly why they make certain, let's say, statements where incoming product is assumed to be good. But yet we put it on the FMEA knowing in reality, it's not always good. Always good is a fictional place, right? There's always something that gets through. So that's really the third bullet here. I want to connect in the handbook with why it was written that the incoming product is assumed to be good, because that is one of the most frequently asked things we get as instructors. How can you assume everything is good when the reality speaks to something different? And once I kind of share that with you, it's not fair for me to kind of give you the answer, but not give you some techniques to achieve it. We're going to be talking about 3 principles, and that term principle is very important. A principle really means a broad brush concept that you hold true. So a principle is executed through tactics, let's say, or legalism. So we're going to share with you 3 frameworks that you can use to get a more effective FMEA when it comes to your incoming product control. And then lastly, we're going to wrap it on up here. So let's go ahead and get started. Again, I'm going to be your speaker for today. We're all good there. Let's go ahead and start with why this is needed in industry. Now, this is needed in industry because 1, the incoming product is a fact of life. Now, the first paradigm that I'm really going to shift, we use the term supplier management. We use the term supplier control. But here's the trick. What COVID especially has taught us, and even before then, we are not actually in control of our suppliers. We are actually at the mercy of our suppliers. Now, understand exactly what that means. Typically, in most organizations, we need them more than they need us. And for all of the SQEs out there, all of the quality managers and traditional quality folks, that's a really hard pill to swallow because it means you're not at the decision side of the table, you're actually on the reactive side of the table. So the 3 principles and a lot of the framework for this seminar is going to work under the assumption that you don't actually have control of your suppliers. You are at the mercy of your suppliers. So you, as the entity, are going to have to find a way through, okay? Now, the second thing, most companies that I've been involved with, that I've worked with over the last 20 years, engage in some form of incoming inspection. Incoming inspection is largely, I'll say, the most popular version of checking parts to make sure before they go onto the line that they're quasi good. Plus, the third bullet here, most people out there will agree that incoming inspection passes far more bad components into the production streams than they should. Many of you have put in subsequent checks into your processes based on the fact that incoming inspection is largely ineffective. And the 4th bullet, which kind of ties back to the first, we have a flawed sense when it comes to command and control toward suppliers. We have learned that, again, we need them more than they need us. And anybody that's on the, say, other side of the negotiation on the contractual side understands exactly how back and forth this is. So as we go from company to company to company, within industry, this is quickly becoming the reality, and it's even more so prevalent than it was, say, even in the 90s. So that's one of the reasons why we put this seminar together. Now, for those of you that have been in other seminars with us, it is time for our poll. Now, what is a poll if this is your first time with us? We like to have the interaction with you out there in webinar world. And so what we like to do is we usually have 2 polls in our training, and this helps me as I go forward, take the canned information and also tailor it a little bit to the poll results. This also keeps you engaged to make sure that you're not snoozing. So I'm going to go ahead, I'm going to launch our first poll. Now we're going to give you a second here. The first question, how does your organization handle incoming product? We have incoming inspection, certificates of conformance. Some of you say there is no incoming inspection. The second question comes back, how effective do you consider your incoming inspection to be? And the third one is, how much effort do you put in? Now we do this for 2 reasons. 1, it gives me an idea of who's out there on the other side of the screen. The second thing that it does is it shows you that you are not alone, right? Most companies, you'll find that you're unique in your situation, but not really that different. And if you've taken courses with me in the past here, webinars, you know I stopped the fun at about 70% participation. So I wait until we get to about 70% before I stop the poll. So we'll give you a second here. Currently sitting at around 50%. We're almost there, folks. All right, I'm taking a look at how it's stacking up. It's right where I expect it to be. You never know these things until you do the polls, but you have some expectations around where they are. All right, we have hit 70%. We're going to go ahead and we're going to end this poll here. Partially because the numbers don't change that much once you get to that level of participation. All right. Now, what I'd like to do with you folks, I like to share the results with you. All right. So I'm going to share with you who's on your left and who's on your right. Most your companies engage in incoming inspection. Some use certificate of conformance. Now, notice here, very few of you have nothing. And then some of you review the supplier data, the minority do. However, despite the fact that a majority use incoming inspection, most of you consider the incoming inspection slightly effective. All right, so that's not too good there. That's rough. Now, the third one here, when we take a look at effort. So some of you are putting in a lot of effort. Some of you are putting in a little effort. For those of you that are putting in a lot of effort, seeing minor results and utilizing incoming inspection, the question that I have for you is, why do you continue to do it? Now, the principles that I'm going to share in this webinar are geared toward getting that process more effective at handling the incoming product. So I'm going to stop my share here. And let's go ahead now and take the next slide. Now, for those of you that are using AIAG VDA FMEA, and it was kind of this way in 4th edition too, they go through and they use the term in 346 in preparing the FMEA, assume the incoming part / materials are correct. This by far is one of the biggest things we see during our PFMEA classes, and the question that every instructor gets, I guarantee you I'll get it next week when I do the one I'm doing next week. Now, notice here, exceptions can be made by the FMEA team where historical data indicate deficiencies. So what this is saying is, if you're an injection molder and you know that your particular resin house continually sends you material that might be mixed, different grade, high humidity, whatever you want to call it, you can include it on the FMEA. But here's what I want you to understand. The intent of this is that you manage by exception. You don't put in every direct material into the FMEA. So how do you handle this, knowing that not all of our materials are going to be perfect? And so we need to go through and we need to give you some tools in order to do this. Now, notice the note in the upper right-hand corner. From the handbook, when you talk about the work elements or what we call the 4 M's, you only should list out indirect materials. So we're talking about, if you're a machinist, right, the coolant. If we're talking about different greases, we're talking about different evaporants. So how do we do this part, right? Let's take a look at how this works in the actual structure. Now, here's the example. We're going to go ahead and we're going to look at Op 30. Now, follow with me here, right here. We are making a brake pad assembly. So we are taking the back, we're applying it to the shim. So pad goes onto shim. And what happens here, this is part of the disc brake assembly line. The thing we are looking at is the pad shim alignment. So this thing has to go in a certain way and it's got to be aligned. Now, traditionally, we will have an assembly associate, right? Somebody that is securing these. And this is where the ambiguity comes in. The brake pad and the shim are your direct materials. Now, notice here what we have, and I'm setting the stage here. Every work element has a function, and every work element's function has a process characteristic. The question is, why don't we include these things right here? Now, I'm going to start in with the three principles at this point, and all I need you to know about this is we're attaching the brake pad to the shim in this operation, and the pad and the shim are considered direct material. The first principle that I want you to really get deep down in your soul here when we talk about improvement, you are only in charge of your own resources. This is the first principle. So what do I mean by this, right? Let's take a look at this. When I say you are only in charge of your own resources, when you look at the ISO 9001 standard or the IATF standard, right? They all use the same words. The three most powerful words to describe this principle is responsibility, authority, and role. Now, notice here, responsibility must be balanced with the authority to execute based on the fulcrum of the role you play in that process. Now, this works with human beings, and the way that I work with this when it comes to the human factor, you can never give someone a responsibility without giving them an equal amount of authority. If this becomes imbalanced, blame is the inevitable result, all right? Too much responsibility, not enough authority. And what we want to do here is we want to take these three ideas and we want to apply them over not to human beings, but to the process. So here's the way we're going to make this transition. You can never give a process step a responsibility without giving it an equal amount of authority. Now let's take a look at it in the brake example. Right here, we have the brake pads and the shims getting pressed in with some grease by an operator. So traditionally, this is how we see this principle play out. Now, down here, you guys have to be a little bit familiar with the AIAG VDA. If the alignment is off center, so how we put the brake pad onto the shim, we end up with 100% rework, plus all the DFMEA problems. And so this is traditionally what we see in your FMEA. The incoming pad profile is no good. Now, let's break this down for a second. What we are doing, we are blaming a direct component when it's attached for the misalignment. Now, let's go back to those three words: responsibility, authority, and role. If I am over here at this station, does this station have any authority for the incoming product of the brake pad? This station? No. No, it does not. So I cannot task this station with a responsibility, with a function that it does not have the authority to carry out. Now, what you'll see on other slides here, and I want to introduce this. If you task a station with a responsibility that it doesn't have the authority for, what you are doing is actually complaining. That's the trick. This is what we see in everybody's PFMEAs. The reason why you do not put the direct material in as a work element is because you do not have any authority over that direct material. Can Operation 30 go back to that supplier and force them to make a good part? No. Can this operation at Op 30 go back to incoming? No. So you can't task it with the responsibility because it really has no authority to make any change. What you're in effect doing is blaming the station for the incoming part quantity. That doesn't work. This is ineffective. This comes back to the first principle. You are only in charge of your resources. And at Operation 30, guess what your resource is? The operator. So here's the way you approach it. Here's the mind shift to do it differently. You look at your operator and you say, the operator is my resource. How can I task the operator with the function? And now, for those of you that are familiar with functional analysis, you can only task the operator with validating the incoming product. That term validating or verifying is important because can that operator assure a good part? Absolutely not. It's not in charge of the incoming parts. But is it in charge of its verification process at Op 30? Sure. That operator can do anything within the realm of that station. So the way that this should be represented for maximum effectiveness, we still have the alignment being off center now. Stay with me. We still have the rework being the potentiality of the effect. But what actually caused this alignment? My operator at Op 30 failed to verify the incoming material. Because am I in charge at Op 30 of this operator? Sure. This allows me to target my preventions, not around making the part good, but about making sure that my operator doesn't fail to verify. This leads to effective prevention. That's huge. And it also leads to effective detection because if I can detect that my operator failed to verify those parts, then I can put in an appropriate detection. This leads to a higher quality of event because you are targeting the responsibility of the station with the responsibility of the operator at that station, and you have the authority over what that operator does as part of their standard work. This is huge. Now, notice at the bottom of the screen, if you're following along out there, this should make you wonder, why do we have to do it if we have incoming inspection? Folks, that is the right question you should be asking. If you are having to validate incoming material at every single process step, why are you paying for incoming? This is going to lead us into principle 2. I'm going to show you how to read the FMEA. Now, let's take a look at principle 2, because now there should be a tremendous amount of, say, anger over the fact that incoming inspection has let you down. But here's the thing that you need to really fully understand. You need to learn to re-look at the PFMEA and understand that everyone is passing risk to you. So if I am on Op 30, everyone introduces risk to me, even Op 20, even incoming inspection, even the supplier. So let's take a look at how this works. Now, over here on the side, risk is ever present, right? You can never eliminate risk. You can only manage it. What I'm going to ask you to do today, reevaluate how you read the S, O, and D values in a PFMEA. Folks, I want you to think of the PFMEA from here on out as a communication tool. If you are in supplier quality, the PFMEA from your supplier is a communication tool about what they're about to do to you. Now, what do I mean by that? Let's say right here, right? Let's say that I am submitting this PFMEA to you. Now you're in supplier quality. When I put a severity of 8 down, I'm telling you you're about to be impacted. When I put an occurrence down, anything other than a perfect 1, am I promising you that this failure, the operator failing, will never occur? No. The occurrence value is an admission of risk. And when I give you a detection value, unless it is a perfect 1, did I promise you if it happens that I will always detect it? No. So here's the thing. If I was your supplier and I submit this PFMEA to you, when you sign a part submission warrant, you are taking this risk into your manufacturing operation. This is huge. When you learn how to read it from that perspective, I am telling you my risk profile. And now, if you read it like that and you read it correctly, can you then put hard tooling fixes inside of your line? Can you strategize incoming inspection more efficiently? Can you put detections in station, validations in certain characteristics? Yes. This is how you are supposed to appropriately read an SO&D. It's a communication. So if I know if you ship me a bad part, I'm going to be impacted. The chances of it happening is pretty good. And if it happens, you really don't have a great way to detect it. I now need to protect myself. This switch is huge. And when I say this is a paradigm shift, we have been trying to command and control the supply base for far too long. When the supply base gives us their FMEAs, they are communicating to us the potentiality of their parts risk in our process. We need to learn how to listen. And then we strategize in line to make up for the high risk areas. The fact that this is a high risk, I can either be disappointed when they send it to me, or I can be anticipating that they're going to send it to me. I am always going to anticipate that they're going to send it to me. Now, this is from the external side, right? This is the supplier side. What do you do with those in-house processes? Let's pick on incoming inspection because it's the exact same thing. This is a PFMEA excerpt of an incoming inspection process. So the failure mode, incoming inspection, failed to segregate. This gives us a 7 because the inspector failed to inspect through the entire lot range. The inspector did not pull parts from the whole range. Now, what do we have to help them do it? There's an inspection plan. But here's the trick, folks. Is that anything other than a perfect 1? No, that's a 4. That's saying there is a very real chance our inspector will not pull through the entire lot range and their sampling will be woefully unprepared. And right here, if they don't pull through the lot range, I have no detection to say that they missed parts. There's nothing in my system, my inspection system, that tells them, hey, by the way, you might have grabbed 15 parts, but it wasn't representative of the entire range. Now, think of it this way. If you are the customer of receiving inspection, how long do you think it's going to be before they fail you? Not long. Folks, when you read the PFMEA on incoming inspection, it's exactly the same as a supplier PFMEA. It is the opportunity for them to pass a bad part onto you. So if I am operation 20 and I'm bringing that incoming material in, or I'm op 30 in the brake pad case, guess what? There's a very real chance the inspector will not inspect the brake pad through the range. And I really have two options. Either I get surprised when they miss it and send it to me, or I can be prepared and anticipating it. The general theme, folks, and the thing that I want you to understand about this, when you use the FMEA, every station, its output, its risk profile is an admission of risk of getting something passed to the next area. And if you understand that, it allows the next station to protect itself, but it has to be from an anticipatory standpoint. So this is one of the reasons why we want all incoming parts to be considered good. Because if we just continually inspect each and every step and we never get back to the risk profile for the subsequent station, you're not putting the actual correction where the authority is. It leads to bad behavior. Now, summarizing principle 2, the SOD values in each FMEA are an admission of risk. Risk must be evaluated for each step for proper mitigation. So if I'm at op 30 and op 20 is drying and it's a molding operation, I need to look at the PFMEA for 20. I need to look at the chance of them failing me, and I need to protect my neck at op 30. You can only deploy your own resources to protect yourself based on risk factors outside of your control. Never, ever, ever count on the supplier to be your protection. Okay? That's a failed mission. Supplier management is about relationship management. And when the supplier passes you the PFMEA, you have to look at the risk profile and then build into your line the things that protect you, because it is your name that goes on those parts. So control outside, that's an illusion. That's something we make up. And the risk is compounded at each step through, if you're familiar with row throughput yield, that's a really good way to look at the compounding of risk as it goes from station to station to station. Now, before we go much further, I'm going to come off here and I'm going to go eye to eye with you. So principle 1, you can never task a station with a responsibility, like assuring incoming good part, that it does not have the authority to do. So you have to switch the functionality of some of your work elements. That will lead to a better detection if incoming product is found, so that it doesn't get passed on. The second thing you have to do is you have to treat each station like a subcontractor to the next. And when I look at op 20 and I'm strategizing how to control an op 30, I need to look at the risk profile so that I can put into my own process things that protect me. This is how it works. Now, the next step here, the 3 principles. You know what? Let's do a poll beforehand. All right, because we talked a lot about suppliers. Let's go ahead and do our second poll. I've been John a lot. All right. Second poll. What risk mitigation methodology do you require from your suppliers, if you have suppliers? Do you review the risk profile for supplied components when doing your own process design? Folks, number 2 is huge. And in your sampling, do you use dynamic sizes? Now, what do I mean by dynamic sizes? If you have a 1,000-piece slot and a 100-piece slot, do you check 3 parts regardless of size, regardless of performance? The PFMEA from subsequent operations is the single biggest indicator of where you should be verifying and validating, because based on that risk profile, it will allow you to put in the right controls into your process steps. All right, we're at 50% there. All right, 60% and climbing. All right, we are doing well here. Right, we are cresting up there and we have hit it. All right, let's go ahead and end poll and I'll kind of share with you what your peers are doing. All right, a majority of you folks, let's do this. A majority of you folks are using the AIAG 4th edition. A fair number of you have transitioned over to the AIAG VDA handbook. I will tell you between the two folks, the AIAG VDA handbook really drives this point home of the responsibility and the authority. The structure in that one really helps organizations get there. Now, when it comes to whether or not you review the risk profile for supplied components, wow, that one really couldn't be more evenly split, even if we take out the not sure's. Some of you do, some of you don't. For those of you that don't, the PFMEA from your supplier is the realistic risk profile. It is the key to what the PPM is that's going to be passed to you. They're literally telling you where your risks are so that you can fortify. That's how you use it for incoming materials. And then in your sampling, a lot of you, a fair amount, almost evenly split, do use dynamic sample sizes. Cool. All right. Now let's take a look at the third and final principle. Now, this is one of the things that in my career I have used a lot. And now, depending on your scope, depending on your industry and your commodity, some commodities require a higher amount of rigor, let's say, in their sampling methodologies. So never let this advice dictate how you do it if you know that you're in a certain realm. The third principle, sampling is strategic and really needs to be driven by the FMEA. Now, the way that we do this here at Plexus, too many people put too much faith in sampling as a tactical tool. They look for that magic mill standard, that magic, table. That's not going to work. Now, in planning to protect your station, we have found at Plexus that we like to teach the 3 S's. These are routinely the biggest challenges that people have. The first area is that of sample size. So let me kind of explain how this works. In statistics, there's a rule, right? As close as it comes to rules in statistics. The smaller the shift you are trying to see, the more samples you will need. Now, what do I mean by this? Let's say that you have a machining process and it's 10 millimeters plus or minus 0.5. If you are looking for a tooling break, and that's a huge shift, right? It'll go up to like 11 millimeters, let's say. You don't need very many samples to see that big of a shift. It's going to be very apparent. But if you are looking for tooling wear and you need to be able to detect a variation of say 0.02, you're going to need many, many more samples. Now, to illustrate this, let me show you something here. There's a really fun game out here. Just bring it up for you. This is one of my favorite games to play in training. Let's go ahead and speed this up a little bit. Now, in this game, there's a 50-50 chance the ball goes to the left or to the right. And statistics says that given enough observations, you should get a normal bell curve. This is true. Now, let's say that I want to add wicked variation, like 90-10, right? So now there's a 90% chance that it'll go. How many samples do you think I'm going to need to see that something shifted? One of these things is not like the other. Did it really take 19 samples to figure out that there was something wicked wrong? No. Now, if I want to go for the long con, right? Let's go ahead and do 60-40. This is smaller variation, right? How many samples do I need? It's kind of looking like a bell curve. I'm not too sure. It might be something wrong. All right, right about here, you can tell that this is not the same. You're definitely skewed over to this side. This took 42 samples. And so if you're looking at improving your incoming part quality that gets in through your line in incoming, your sampling strategy must consider the amount of risk that you can endure. And how would I look at that? Severity and your supplier's capabilities. If your supplier is barely capable and the severity is high, you're going to need a whole lot more samples than you are if your capability is outstanding and it's, say, a low severity item. Now, the second S has to do with stratification. Stratification is a fancy way of saying the part demographics. So, as an example, if I am getting incoming product, let's say that it is a machining operation, and I know right here that particular, let's just do a machining oil is key to dissipating heat. What happens if they cycle the machining oil 3 times a shift, but I'm only sampling incoming product in a lot that represents once per day? Am I going to miss shifts? Oh yeah, 100%. Or let's say it's appearance parts, and I know that the lighting makes a difference. And the way that the factory works, the lighting in the AM is different than the lighting in the PM, but I only inspect the product from the day perspective. Is my sampling going to be effective? Absolutely not. And if a machine operator switches every 2 hours and you are only sampling the lot at the day level, you're going to have possibly 12 different operators that have set up that machine. Every 2 hours they fluctuate, and your sampling is going to be inefficient. So when we look at the stratification strategy, we like to use fishbone, which again is driven by the PFMEA as failure causes. Sample size, we already talked about. Frequency must be based on risk. In this case, it's the risk of missing one of the variables. So even if you have an awesome control plan, sample size and frequency can absolutely tank it. So one of the things we do here is we like to use the fishbone diagram to strategize our control plan sampling. From sample size, we know how many we need to check, but nothing outside of looking at the PFMEA is going to tell you how often those variables may shift in your supplied product. And the last one, this one's simple. This one's subgroup. Once you sample and you've got the right frequency, the right stratification, the right sample size, how are you going to subgroup? Are you going to do singles? Are you going to do 5-piece subgroups? Are you going to do 9-piece subgroups? Larger subgroups form more representative values, but you have to be able to balance the cost and effort. So principle 3, I gave you 3 S's here, but the overarching principle is the sampling must be strategic. I have seen 100 control plans and incoming inspections tanked by ineffective sample size and frequency. So wrap it up here. Principle 1 is you are only under control of your own resources. Principle 2, you have to look at every input of the station from an SO&D perspective as the admission of risk that is passing on to you so that you can effectively leverage those resources. And step 3, once those resources are in place, you need to strategically sample to make sure at the tactical level, you're able and good with the, say, sampling plan when those resources do what they've got to do. If you understand that, and you understand that all of this information is publicly available in the PFMEA that is supplied to you either by your supplier or from the station immediately before the one that you're currently strategizing on, you're going to be able to craft a much better control strategy because you're now taking responsibility at the station that has the authority, not just blaming incoming inspection and wildly swinging. Chris, are you with us?
Yes, sir. Thank you. And thanks so much for sharing today. Before we get started with question and answer time, I'll let you folks take a moment, submit your questions for us, for Jeremy, regarding incoming materials or something else maybe you can think of right now. We'll take the last few minutes of this hour to answer those. Just a reminder, for more information regarding incoming materials, we actually have a few little short videos around this topic on our blog, on our website, plexusintl.com, or on our YouTube page, Plexus International. So with that, Jeremy, I'll start with some questions. They're from earlier on in the presentation, back when we were talking process FMEA. The first one, I want to just challenge you real quick. We're not sure, Demas and I agree, we're not sure if it's necessary to approach the concepts of authority for the explanation. I think it was in slide 4. Wouldn't failure and function concepts be enough for that?
But now here's the trick. If you have the failure and the function concepts, we need to understand that you can never task a structural element with a function that it doesn't have the authority to carry out. So let me give you a real life example here. When we look at boring a hole in a part, we're tempted to say that this operation bores a hole in the part. But if you have a drill and a bit, the bit cannot bore the hole without the drill traveling, rotating, and holding it. See how the drill has 3 functions? Meanwhile, I cannot task the drill with boring the hole without the bit physically removing the material. This is some next level functional thought, and this is what the new AIAG, VDA, FMEA does that the old method didn't do. So the responsibility authority conversation is very, very important to get your resources working in a function that they can actually influence. Because if I task the drill with boring the hole and it doesn't have a bit in it, it's similar to a bullet in a gun, right? The bullet just sits there. The gun just sits there. They each have a role to play, and it's through the interaction that they take shape. So I have to have a function for each. Nope, this is some next level stuff.
Thanks. Here we have one. Doesn't the operator verifying now become a work element? And with that, don't I have to address type 1 and 2 error of the validation?
100%. Yes. What if they pass a bad part? What if they reject a good? You're right. Those are both failure modes of that operator having the function. You're actually having the exact right discussion, because now prevention can be limited, not about the part being good or bad, because that doesn't matter. The operator can't control that. But now the conversation around prevention becomes, how do I prevent them from passing a bad, or how do I prevent them from accepting or scrapping a good? Yes, that's what gives you a much tighter control. You're having the right thoughts. So you're just talking about 2 failure modes for that operator, 100%. But now they're your operator. You're not blaming the part going, they took away my birthday. Yeah, that's just complaining. Yeah, you get it.
I like it.
It's getting it.
We've heard a lot that the FMEA is not allowed to be shared with the customer because it contains internal information and know-how. Is this correct?
Yes and no. Let me go 2 steps with this. It is not uncommon that design FMEA is not shared with the customer in its entirety for litigation reasons, right? Because it does have some proprietary functional and safety information. PFMEA for some applications could be that way. Let me give you a perfect example. A heat treater. A heat treater's, let's say, settings are their secret sauce for how they heat treat. And we have had less than, let's call them, we'll call them customers with low integrity that have taken a heat treater's special recipe and shopped it to other heat treaters. So here's the way it works. There is no black and white as to whether or not you can or cannot share anything. The question is going to be, what are you willing to share? And if you're not willing to share, it's a contractual obligation between you and the customer or you and the supplier. And a lot of times, if there is that contractual obligation where you're not going to share, there are bits and pieces you have to at least communicate, such as the effect of a product failure through a process that you're having done for you. That processor needs to know if they get that diameter wrong, what happens to your part. So that kind of information still needs to be shared. Yep, good question.
Mhm. All right, so we'll flip that the other way. What are some strategies for gleaning information from a supplier FMEA when the supplier does not submit due to proprietary reasons? Maybe review on site, but not take a copy yourself.
That is, in a best case scenario, that is my preferred method, is to go on site and review. And when I do that review, I'm just looking at it and I'm going in with the intention of the tool, and I'll give you a tool here, the characteristics matrix, right? There is a tool in manufacturing. We didn't cover it here because it's not quite within the realm of this. A characteristics matrix takes the characteristics that are given and distributes them amongst the stations. So if you ask your supplier to do a characteristics matrix, say they're making 4 characteristics on a flange, they'll tell you which stations they're created by. So at least you know which stations you might look for a higher level of control and have a conversation with them. That's not uncommon that the supplier won't share it. So you have to have some creative ways to get it. And what you're really looking for, what are the most important and frequent logical things that you're going to pass to me that I need to protect myself with? And when I go to suppliers and I ask that question, they're willing to give that information because what they want me to catch it at least, so that we don't go 3 levels up to my customer and my customer's customer. And now they have an increased warranty issue. So suppliers are more than willing to give that information, maybe not the document.
Great. Well, let's keep pulling this thread of supplier FMEA. Regarding the risks on our supplier FMEA, do we have the chance to not accept it? In PSW, we can decide for putting conditions in conditional approvals or either reject the PPAP.
All right, I'm going to be completely honest with you here. Okay, this is 100% honesty on this one. When they submit a PFMEA, you always have the opportunity to not accept the risk profile, right? You can say, hey, we've taken a look at the risk profile, the PPAP, and we're not accepting it. But in my experience in quality, if we were supposed to sign the part submission warrant on Thursday so that we could do our build on Friday, I was told in quality, find a way to live with it. So when I say I'm going to be completely honest, it's happening. You just have to find a way as the quality group to be okay with it. That's the reality of the world. But yes, you do always have the right to reject it. And the nice thing is, with supplier PFMEAs, I try to review them as early in the program as possible, because if I see a high risk profile that I want to influence, it gives me the opportunity to discuss better detections, better preventions, or different ways change the work elements from manual to automated. You can't have that discussion at PPAP submission time. Ship's already sailed there. So yes, you can reject it. I can personally say I've never rejected it. I've had to fill out a conditional approval and found a way to live with it. Yep.
Nice. Here's one. Inspection activities should be analyzed by MSA, correct? Part 2, what failure mode should be considered for incoming inspection?
Okay. So measurement systems analysis is about the gauge that you use during inspection. So without getting too weird, can we take business process metrics like inspection and apply MSA studies for the validity of the process? Sure. When you talk about failure modes, think about what incoming inspection gets paid for. They get paid to segregate the bad and pass the good, right? So therefore, when you do the PFMEA on incoming inspection, The operator is supposed to fulfill the inspection plan. Doesn't fulfill the inspection plan. The operator is supposed to segregate the bad parts. Fails to segregate the bad parts. The operator is supposed to check the full quantity on the inspection plan. Operator checks half the quantity on the inspection plan. See how that works? Everything you ask the operator to do in incoming inspection, the reverse is the failure mode. They're supposed to check 5, they check 4. That's the failure mode. I would highly recommend you do a PFMEA on the process of incoming, not just incoming as part of the larger line PFMEA. That really helps your incoming system. I personally do a PFMEA on every one of my QMS processes, from non-conforming product to corrective action to document control. Every process in your QMS has the opportunity for a PFMEA. I do one on incoming inspection as well.
Great, thanks. I think there's been 2 questions. Maybe you could recap. What is dynamic sample size?
Dynamic sample size is different than static sample size, and I'm using those two in a very common language. Static sample size says if my performance changes, like, hey, I start passing more worse product, or I start getting better at passing less worse product, I might adjust the sample size based on performance. Hey, my supplier submitted capability data that says their capability is getting worse. I'm going to up my sampling to make up for the bad capability, right? Static sampling says, I check 5. Well, how many did you do last time? Same 5. What if the performance gets better? Still staying 5. I call that the atmospheric extraction method. You reach up into the sky and you pull it out of nowhere, and that's the number. Yep. So dynamic as opposed to static.
Gotcha. So we'll take just one more here as we finish up the top of the hour. I do want to thank everybody for joining. Again, if you do need more resources, want to watch some more Jeremy's videos here, do visit our website, plexusintl.com, or reach out to us, contact us with any more questions. We're here to help provide services to you. So with incoming materials, could we apply these principles for services?
100%. Even with services, right? You are a service provider. Let's say you're a service provider, and I don't know who's out there in webinar world. So let's say that you're a service provider like a home loan, right? Processor. Absolutely, that's a service provider. And whoever, let's say you get your computer software from another company, that's an incoming product, right? Downtime on that software is going to have an impact. So you can either blame the software provider for the downtime, or you can say, we're going to go through and we're going to do something a little differently, and we're going to have a contingency. Now, if you're a service provider, let's say for a manufacturing site, like you do corrective action systems. Absolutely, you get inputs from the corrective action system. Part of that corrective action system is getting the notification that a corrective action has been initiated. Is there a real chance that sometimes you may not get that notification? Yeah, 100%. We've all missed them. So you could apply the same concepts, 100%.
Great. Well, thanks a lot for your time today, Jeremy, and thank you everyone out there in webinar world. We do appreciate you joining us.